That's what they call it, Cli-Fi.
Okay.
And so,
What's Cli-Fi?
it's like how they've always been romanticized like energy sector, like the coal miners, those tough big burly men going in there,
Right.
or like those strong men harpooning the wells, how
Oh,
romantic.
oh,
that
right,
is.
right,
And
right.
now like being in the oil field now, it like represents trash,
Yeah,
and so it
yeah.
was just funny seeing how like the
Right,
the
right.
English can even get into it, like gosh,
Yeah.
everybody's concerned now, even if the English department's concerned.
Yeah,
It's a real deal then.
yeah,
It's just funny how they can tie in so many different pieces together,
yeah, yeah. Okay, guys, so I think we're in pretty good shape here. It's week 12, and we are halfway through chapter 12. We'll do chapter 13. We only have one day next week, but between, now let's just look at the calendar here really quick.
Thank you for opening that up too.
Oh, sure.
Yeah, thank
Yeah.
you.
No, I didn't,
We only have 4 things left, right?
yeah, there's the problem set 2 is due this week, and I think we covered a lot of that. If you want to do a little bit of that today, we can. Summary 5, exam 6, and then that last problem set. There is a final that you're welcome to take. It's quite challenging. The point of it, though, is if you really tanked on one of the exams, you can use the final as a bonus. I suggest taking it anyway. It's just, it's fun. It's a good brain teaser, get you thinking.
It's just accumulative.
And then a question too,
It's-
like when a lot of the stuff that I submitted,
Yeah,
like isn't graded, like it wouldn't be graded, but then I would, like the 2 attempts, I'd take the lowest grade and put that on as my grade.
no, I don't know why that happened.
And then-
Peter
and then
will
the
take
second
care of
attempt
that.
That was like the better grade. It
Yeah.
just said not graded yet, but it took the first grade.
That'll
It'll
be,
work out?
we'll mop that up.
Okay.
Yeah, it's not a
Because I
big
go to
deal.
my grades, overall, and I'm like,
You're
I
okay.
can't be that bad.
You're
no
not,
way.
you're not, you're not, you're not.
Okay.
Okay, guys, so this is week 12. I'm gonna call this week, 13. There's Thanksgiving. We can call this week 14. And then, let's see, week 15. This is actually the last day of class. So we actually have, sort of an extra day or two in there. We're in good shape for the syllabus. Okay, so here's what I want to do today. This chapter, costing energy, I think we took a pretty deep dive on Tuesday into kind of what money is. We looked at kind of briefly at the Nash bargaining problem, and today I actually want to look at some specifics in terms of the time value of money. And this will have, we're not going to get specifically into PPAs, which are power purchase agreements, but that's basically how all these large energy projects are negotiated, established, et cetera. So we will look at the specifics of how money gets paid back.
You said that acronym was PPA. What was that?
PPA, yeah.
Sorry, I just want to.
Oh, yeah, no, it's important. I'll just write it down. I will write that down. So a PPA is a power purchase agreement.
Thank you.
And it basically means, yeah, absolutely. It basically means I'm going to build a dam, I'm going to build a coal-fired power plant, I'm going to build a nuclear reactor. It's going to cost a certain amount of money now, and then it's going to get paid back over time. Another thing we will look at is the payback period. And we can even do a, let's just do a simple analysis right now. We'll start off with something. So let's just say I have 2 light bulbs. Now let's do this on my own. And one is going to cost you $5 now, and another one's going to cost you $1 now. And then, let's say the $5 light bulb now, let's just say that that's going to cost you 10 cents a month to run. And let's just say the $1 light bulb is going to cost you a quarter, 25 cents per month. What I'm looking for is the break even on this. So let's do that. Let's just do that. So you're gonna have this will be the high, this will be the LED, and this will be the incandescent. So it's, the more expensive light bulb is going to cost you less per month. Same number of lumens. The less expensive one is going to cost you more. So let's look at the point in time where the more expensive one starts saving you money. You got it? Got it written down? Okay, I'm going to turn the screen off and then we'll
Let me write down, hold on one second.
write it down. $5 now, 10 cents a month, $1 now, a quarter a month.
Equals 10 cents a month.
Okay,
I like that.
ready? It's pretty simple. Ready, set, go. Ready?
Yep.
Okay.
So I screwed up.
Well, I probably just didn't explain it right. I'll show you what I was up to here with this guy. Okay, so what I did it a couple different ways. I first drew a picture. So again, I'll restate the problem statement. And the problem statement is when does the more expensive light bulb, you're like, oh my gosh, I'm going to spend 5 times more for this light bulb. Why would I do that? Well, it's going to cost you less per month. So the question is, when does it actually start saving you money? When does it start costing you less? So I plotted money on this axis, on the ordinate, and I plotted time on this one. And I just started out to make it relatively simple. I put $1 down here, and I put $5 up there. That's how much money you're spending at time 0. And then I said, well, in 1 month, I know with that $1 bulb, I will have spent an extra quarter, and then 50 cents, then 75 cents. So by the time I hit 4 months, I'm going to be up to $2, etc. So every 4 months, I'm going to spend another $1, and here that goes. So this is the slope, and I just kind of carried it out there for the $1 bulb. And then for the $5 bulb, I said, okay, it's time 0. I'm going to spend that $5 now. In 10 months, which is right here, I'm going to have spent $1, right? Because a dime a month is $1 in 10 months. So this slope is flatter. So you're even though you spent more money initially, you're spending less money over time. Okay, so now we've got a nice figure on that. I got up to 16 months, 20, and I know it's going to be somewhere out there. Now, I took that and just converted into 2 equations. And, well, how many unknowns do I have? I know that this is a function. I know that the cost is a function of time. And it's just linear. This is my initial cost. This is my cost per month. And I just let t be the number of months. And then for the cost of the $1, I just called that C1. I'm going to spend $1 initially plus a quarter a month. So C5 equals $5 plus a dime a month times T, which is the number of month. C1 is $1 plus a quarter a month times another month. So I just took those 2 equations. These are my initial 2 equations. And I know at some point in the future, these two costs, so again, this is the C5 line, this is the C1 line, they're going to intersect somewhere out there. And when they're equal, I just made them equal. So I just took the top equation, put it here, bottom equation, put it here, ran out of room, so I sent it up here. So 5 minus 1 is 4. 0.25t minus 0.1t is 0.15t. Now, I'm in great shape because I have one equation and one unknown. And in order to find t, I know that t is just 4 divided by 1.5, and that's right around 26.6 months. So, 2 years. And you might say, well, how long does the light bulb last? You better, look to make sure the bulb's going to last longer than 2 years, and if it does, and we might say, well, gosh, if I can't guarantee, if it only has a 1-year warranty, you might want to look to see if it's actually going to, pay for itself. Okay.
Yeah, I wrote 2 equations, but I replaced months with 12 because I wanted to just get them both side by side on a year basis, and then I went up by increments of 6 months, splitting the amount that I got from that original equation in half, and then just adding up as I went until I got to 36, where the $1 one amounted to $9, and the other one was $8.60. So I backed up 2 months, and then I got $8.40 and $8.50.
Okay, so you kind of did a little iteration. Yeah. So I think this guy just forcing it into a corner with 2 equations, 2 unknowns is gonna get you there. All right, I'm just going to take a quick break on that, and then we're going to get into the time value of money.